Hello friends, today we are going to discuss on the topic current electricity. Let us go to its history. This electricity, this word has been derived from the Greek word electron, which means amber. So amber is a yellow, orange or bluish or brownish yellow resin used for making ornaments. Especially it was used to make ornaments. And Thales in 640 to 546 BC, observed that when amber is rubbed with fur, it acquires the property of attracting light objects like pieces of paper. And about 2000 years later, in 17th century, William Gilbert discovered that such attractive property can be acquired by rubbing many substances like fur, glass, albonite rod with suitable substance. This process of acquiring attractive property by friction was called electrics. So nowadays we call this effect as the electrification. So friends, you may have heard about the famous kite experiment by American founding father and inventor Benjamin Franklin. In 1752, to prove that lightning was electrical, he flew a kite during a thunderstorm. He tried a metal key onto the string and he suspected it would electrically from the storm clouds flown down the string, which was wet, and he received an electric shock. Franklin was extremely lucky not to have been seriously hurt during this experiment, but he was excited to have proved this idea. And now, just we consider Michael Faraday is a father of electricity. He was self-taught scientist. Michael Faraday excelled in chemistry and physics to become one of the most influential thinker in his history. And now he is known as father of electricity, and he has made a invention on electric generator, electric motor, and he also discovered the law of electromagnetism. And to take this electricity in use, generally Thomas Alva Edison has made a electric bulb, so that the current electricity has come into the use and helped in lightening of a bulb. It was used for lightening of the bulb. It was by end of 1880s. It was in 1880s. So Thomas Alva Edison was finally able to produce a reliable, long-lasting electric light bulb in his laboratory. And it was about in 1879 to 80. He was an American inventor. Okay. Now, this is about the history of electricity. Now, we will go to the definition of current electricity. Okay. So current is a flow. Just current is a rate of flow of charge, or it is a flow of charge per unit time. It is a rate of flow of charge or flow of charge per unit time. Let us consider this is a metallic wire. This is what? Metallic wire. It consists of a electron in it. 3 electrons are considered in the conductor especially. So these conductors collide, means they are in vibration, means they collide with the wall of conductor about the mean position. They vibrate here, and just means they collide with the wall of conductor and come to the mean position. Means when electric potential, means when difference is created, means potential difference is created in it, then what happens? They started flowing. Means when electric field is generated, electric field is generated, electric field is generated from positive terminal of battery to the negative terminal. When this is generated, then electrons start to flow toward the positive terminal of a battery, and then similarly, just whereas current flows in opposite direction of flow of electron, means from just by a conventional flow of current, we know that current flows from positive terminal of a battery to negative terminal of a battery, means it goes toward this side, and then the flow of electric current takes place. Means what is electric current? Current is the rate of flow of charge, means flow of charge per unit time. How much charge has flown per unit time in a certain time, that is only the current. Okay. If Q denotes the charge and T denotes the time, then current, current is always denoted by I, and current equals to charge flown upon time taken, CHARG, charge FLOW flown upon time taken, that is equals to Q upon T. Okay, I think you are clear about it up to here. So charge also generally in a time dt, suppose this is in a time dt, how much charge has been flown in time dt, how much charge has been flown, that is known as instantaneous current. So current maybe one is instantaneous, means charge flown in instant time, in a particular time, instantaneous, and next one is a charge flown or average current we can find it, means how much charge has flown in a given time interval or given time. So charge can be current can be instantaneous or average. Instantaneous current can be obtained, means what is instantaneous current? Current flows or charge flown in a certain time interval, dt time, in a certain period, means for a small time dt, how much charge has been flown, that is only the instantaneous current. So it can be given as dq upon dt, whereas average current can be given by total charge flown, total CHARG, charge flown upon time taken. So charge flown to the time taken. So it can be written as Q upon T, del Q upon del T. So it's SI unit generally. What is the SI unit? Can you guess? What is the SI unit of charge? That is coulomb. What is the SI unit of time? That is second. So coulomb per second is the SI unit of it, which is also known as ampere. So this is a unit for current. So SI unit of current is ampere. Sometimes you may be asked, what is 1 ampere current? Then if 1 coulomb of charge flows in 1 second, then the current is said to be 1 ampere. Okay, please note down this. Sorry, okay. I think you have noted. So what is the instantaneous current? Instantaneous means in a particular time how much current has been, how much charge has been flown in that particular time. That is instantaneous current, which is given by dq by dt. And average current means total current, the total charge flown in unit time, a given time. Okay. So generally, we have defined already. Once you try to understand what is current, current is a rate of flow of charge, or flow of charge per unit time is known as current. And what is instantaneous current? What is average current? You should know. So, so what is current? Don't get confused. Current is a flow of charge. So generally, current is neither a vector quantity nor the scalar quantity. So it is neither the vector quantity nor the scalar quantity. Generally, let us consider here, if 5 ampere of current come from here, then when it is dissociated in this direction, then suppose 3 ampere goes in, if 3 ampere goes in this line, and 2 ampere will be there, means it will be dissociated into 3 ampere and 2 ampere. Similarly, you can consider next one also. If 3 ampere come from here and 2 ampere current come from this wire, then what will be the result? What will the current flowing through this wire? That will be 5 ampere. In this direction, they will flow by 5 ampere. But if the angle is 90 degree, if the angle between these two conductors is 90 degree, then this resultant current cannot be obtained by the vector law of addition. Vector law, it have a direction, we understood. Suppose if 3 ampere current flows over here and 2 ampere, if 3 ampere current flows in this direction and 2 ampere current flows in this direction, what will be the resultant current flowing through this direction? That will be 1 ampere. Yeah, that means it follows the direction also. But here what happens, it do not follow the vector law of addition. It has a magnitude, obviously it has a magnitude, it has a direction also, but it do not follow the vector law of addition. If resultant vector has to be found out, then we have to use the Pythagoras theorem, which is not obeyed by this. So this current is not a scalar quantity also. If it was a scalar quantity, it has only magnitude. But scalar quantity has a magnitude, but vector quantity has magnitude as well as direction, and it obeys the laws of vector addition. Yeah. So it do not obeys the vector's law. So it is not a vector quantity. We should know it. It is not a vector quantity. Neither the scalar quantity, because scalar quantity will have only those quantities which can be defined by their direction only. Sorry, by their magnitude only are the scalar quantities, but it needs a direction also, but do not follow the vector law. That's why this is our tensor quantity. We have to write this as a TENSOR. Tensor quantity means neither scalar nor vector quantity. But if scalar quantity, if you are asked whether it is a scalar or vector quantity, then you should say that it is a scalar quantity. You can consider it as a scalar quantity. Means it has a magnitude. No, those quantities which have magnitude are called scalar quantities. It has a magnitude, so you can say this current is a scalar quantity. Otherwise, if tensor word is there, you should understand that it is a tensor quantity. Okay, this is about current, means current electricity. Now let us go to one numeric, then it will be quite easy for you to understand about this theory. Okay, so let me write one question. If Q equals to, what is this Q? Q charge. Okay, what is this Q charge? If Q equals to T square plus 40 plus 5, then in first find current at T equals to 2 seconds, then find two seconds, that is current means current instantaneous. Okay, INS instantaneous, find instantaneous current at T equals to 2 seconds, and find average current at T equals to 0 to 2 seconds. Okay, for the time 0 to 2 seconds, or you can say find the average current at 0 to 2 seconds. Okay, now here this charge means charge is the function of time, no? So look at here, let us take this equation solution. Now let us go to the first one. In first, what is the equation? Let us take the equation Q equals to T square plus 4T plus 5. You know, Q is the charge is the function of time, you know. So here we have to find the current. Current, what is current? Instantaneous current equals to dq by dt. We have learned already. This is dq by dt. Now, let us, to find instantaneous current, we have to find dq by dt. So differentiating with respect to time, respect to t, what we will get? Dq by dt, because we have to find this. For that we have to differentiate with respect to t, because q is a function of t over here. So what will be this? D by dt, t square, this thing you know it. Let me go dt plus d by dt 5. Let us do it. What will be this? dq by dt is current. Obviously we have learned average, sorry, this is current instantaneous, that is equals to dq by dt. Well, but you know, if it has a power will come in front. You know the differentiation rule. 2 t 2 minus 1, that is equals to 2t, plus here what will be this? That will be 4 only, and differentiation of constant is 0. No need to write it. So this is instantaneous current. Now at what? At what we have to find instantaneous current at t equals to 2 seconds. At t equals to 2 seconds. Let us replace the value for this. I instantaneous equals to 2 into t is 2 seconds, means put the value 2 plus 4, that is equals to 2 to the 4 plus 4, 8 ampere is the required instantaneous current. What is the instantaneous current? Sorry. Okay. 2t plus 4. So what is the instantaneous current? That is 8 ampere. Okay. Now let us go to the second part. Let me draw it. We have found instantaneous current, that is 4 ampere. Sorry, 8 ampere. Now let us find average current. I average. We know I average means for what is the formula for finding I average? Average current equals to charge in Q second, from 0 to 2 seconds. During this interval we have to find it. So charge in q seconds, 2 seconds, charge in 2 seconds minus charge in 0 seconds upon t2 minus t1. If we considered this is second time interval, t2 minus t1 gives the average current. So here first of all, let us find q in 2 seconds. What will be the charge in 2 seconds? Use this formula, q in 2 seconds. What will be this? We replace the value 2 square plus 4 into 2 plus 5 column. This much column is the required charge. That is equals to how much? That is equals to 2 to 4 plus 4 to 8 plus 5 column. That is equals to how much it will be? Let us find it. $17 column. 17 column is the required charge in 2 seconds. Now let us find, okay, I instantaneous, we have got this 8 ampere. Now what will be the charge in 0 seconds? That is equals to uh, 0 square plus 4 into 0 plus 5, that is equals to 5 column. Now let's calculate. Now what will be the I average? What will be the I average? Q in 2 seconds. What is that? Q in 2 seconds? 17 column minus 5 column upon, what is that? T2 minus T1 is 2 minus 0, that is equals to 2 only. Can you calculate it? That is equals to 17 minus 5, 12 by 2. 12 by 2 equals to second equals to 6 ampere. 6 ampere. Six ampere. Okay. Thank you, class.